Hello everyone, I'm Greg Weaver. Welcome to the Audio Analyst. Today, we will receive a tour of the current YG Acoustics Factory by Duncan Taylor, YG's marketing manager. Located in the West I-70 Business Center in Arvada, Colorado, a first-ring suburb just northeast of central Denver, the company has seen meaningful change and remarkable growth since my first visit. Now, occupying 7 units of that business complex, and with more than 25 employees, this is not the YG Acoustics you knew before the change of ownership and direction, which began in the fall of 2017. But let's follow Duncan as he takes us through this remarkable, world-class manufacturing facility, allowing us to witness the advances that have been made at this world-class loudspeaker manufacturer. Now, I'll apologize for some of the less than pristine audio tracks, especially early on in the machining areas, given the background noise. But now, take it away, Duncan.
Welcome to YG. We're going to start with machining here on a tour with Greg, and we're going to take a look at how we make things. At YG, we make a lot more of our elements of our speakers than I think anywhere else that you'll find, and it's easily apparent if you follow us through the tour. So we're starting at the back of machining, where we're actually got titanium cages loaded for anodization, and we do a lot of the finishing in this part of it. In the background, you might see a sander that gives us the best aluminum that we have in the slides marked out. What you'll see in there is actually a plate surrounded by a frame, because when you stand in the way, you can't get perfect edges unless you have more material on the edges than what you're standing. So we're constantly going through new cages to make sure that we have the perfect brushed aluminum finish on the sides of our cabinet. This is how it's accomplished. It's all cleaned up by a giant vacuum, thank goodness. But here we're walking into the area where you can see parts that are ready for anodization. So they're done with machining, they're done with finishing, and they're ready to get clear anodized or black anodized. Or any number of colors that we're now doing thanks to our great anodizing partners that we brought on. But as you can see, there's a lot of heavy machinery toward the back. That's where a lot of the magic happens. You'll see a lot of things ready for finishing or ready for anodizing. Here's a cone, for example. This cone was made out of a cutout from a driver baffle. So that's one way we're actually a little bit more environmentally friendly. We recycle everything that we don't use, but anything we don't have to recycle that we can also use is even better. So when we cut out our drivers now on the baffles, when we cut out the baffle holes, we're actually making drops that we can machine drivers out of. So that's a really great update to us there. We're moving through machining to some of the really hardworking machines at YG. Number one is our turret lathe. It's made by Mazak, and its job is to turn circular bar stock into square brackets, or things like this piece, which is one of the pieces that connects our speakers together. We'll have a receptacle that fits perfectly on there, and as you can see, there's a hole through it, so a threaded rod will go through there to kind of strengthen everything. But we make absolutely everything here, including the brackets and the fasteners. Here we can see Tom's loading a new sheet onto a jig in the DMG Mori state-of-the-art CNC machine. This is a 4-axis, and we have 4 of these machines. The 4-axis gives you a lot of flexibility in terms of machining and what you can do. So we can do most of our baffle work and our wave guides on these 4-axis. And when they come off of the 4-axis, they are ready for anodizing. They don't need any finishing. They're amazing machines. Each and every one is the same, represented by the same company, And that company is headquartered 30 seconds away from us. So that's another thing that happened where when we switched to DMG Mori, we have instantaneous support in case any one of these goes down or needs some work. We're also using absolute state-of-the-art tooling. What you'll notice in these tools is little holes that are drilled and go through the tool. So actually what we're doing is we're shooting the coolant through the tool. It's called a chip blaster protocol. And what it does is it forces the chips that come off of the, we call them chips, but the shavings or whatever you want to call it, forces them away from your project so that you're not marring the project, so you don't have to refinish it after the fact. It's a much cooler way to do it, and it's actually like saves a step. So it allows it to work quicker. These machines will make their own jigs, and then you lay the project on them and they'll get to work. So we've manufactured, and here's the oleophobic window. We need to install a new one. I think this one's pretty old. But you can just see basically through what's going on in the coolant to see that these things are just constantly humming, constantly forming, taking, raw aluminum and turning them into a completely ready to go piece. You can see we can do really intricate stuff where if you look closely, the alignment of this woofer is at an angle. And so this requires multiple steps where we'll do one step on one side, align the angle right, and then we'll flip it over to the other side, do the face, then we'll come back to the other side to refinish it. The whole goal, this is a physics design thing. We want the two drivers to coalesce at a predetermined distance. So this being a Tor, this is a Tor baffle, that distance about 6 feet. So it's not a near field speaker where you'll be listening to it on the desktop, but it's a near to mid to large field speaker. We want it to be as flexible as possible. So 6 feet on, it's an amazing speaker. Here you can see an array of jigs that we've already made. Anytime you make a jig that's going to be used again, that's another way that you can save a little time in your process. The biggest thing at YG is how long it takes everything to happen. It's got to be perfect. So we refinish things or throw things away every day that make us cry, but it's just part of the process. We have huge standards, and everything's got to be perfect. So that's machining. We've got a bright room that's as clean as we can make it for this kind of operation. We're going for this kind of cleanliness and environment you want to be in with everywhere that we have. A lot of this work is fairly dirty and it requires coolant and all this kind of stuff. So if we can create environments where it's a lot more fun to do this and it's a lot more beautiful, it kind of is a nicer place to visit. And that's the new YG. We've invested a lot to get here. All the state-of-the-art machinery is brand new, and it's all aimed at that goal. Let's go on into cutting. So what we've got behind us here is brand new to YG. It took multiple trucks to bring it in. It's a giant water jet from the company Flow, and it's an 80 square foot, which means that we can cut so much material on this thing, and it is so much faster than our very precise cutters that you'll see in the back of this room that were what YG has always used to cut out baffles. Very precise. The machine that we'll see in the back corner can cut a human hair 12 times. Yeah, it's that accurate, but it's painfully slow. And so it's something that we had to run 24 hours with multiple shifts just to get baffles cut out. The water jet is, depending on the job, 40 to 60 times faster. So that allows us just to do a lot more and move a lot more product through. And the water jet also deburrs the edges, so they are ready to go into the CNC machines directly after cutting. If you're not familiar with water jets, it's not just water. There's sharpened garnet sand that is also added to the water. So that's what does the cutting. But this shoots at 60,000 PSI, and there's even an accelerator beyond that. So we're able to cut 6-inch aluminum like butter. And it's really been a big asset to YG. We brought it in last year, and we're really using it about 15% of the time. because of how efficient it is. So it's been a great addition. Follow me through to the cutting room. I don't know what you see, but I see driver cones. Right here, this is just a lot of heavy aluminum. And you know what's interesting about aluminum, most people's access to aluminum is aluminum foil or aluminum bikes or whatever. It's all light, you know, very light stuff. Actually, aluminum's very heavy when it's dense and you've got a bunch of it. So we take this very heavy cylinder and we machine it into a feather-like cone over hours and many processes involving multiple machines. And then we anodize it, and then we ship it off to where our drivers are put together and QC'd by one of the world's greatest driver manufacturers. So as a process, it's what allows us to have completely inflexible cones that we can control every aspect of. But more importantly, with the addition of the water jet, we are able to use driver cutouts from baffles and turn them into drivers. So this has been a great innovation, a big efficiency uptick for us, and it's eco-friendly. Behind us, actually behind Greg, you can see our recycling bin. All of this gets picked up every month, and we like to say aluminum comes in at one price and goes out at a very different price, but we do recycle everything, absolutely everything that we don't use. Following us back, we've got some stock of raw aluminum. This is where we start. This stuff is so heavy that there's no way we could pick it up if we didn't have these half-ton vacuum lifts. This is something YG's always been using, is vacuum machines to lift very heavy things. So we'll lift that up and we'll place it on that mill. That's the mill that does 12 cuts to a human hair. It's extremely precise. In fact, it came from an airplane factory. That's where it comes from. It's made for making airline parts, but we've been using it for many, many years to make speakers, and we love it. There's very specific things we still use it for, but it's very slow, so we've really transitioned a lot to the water jet. That in the corner is one of YG's oldest machines. It's a 5-axis lathe, and this is where we make our cones. You can see, I'll show you a couple different steps along the process of making a cone. So you've got this cone is halfway done. We've done the back side of this thing, and you'll notice an odd number of braces. That's very intentional. This is another innovation we've rolled out recently. It's just an update to the cone design. But this one's only been bolted and the back's been done. So we still have to flip it over, put it on a vacuum mold, and then mill out the front of it. And so that will take us a little bit closer to something like this. This is an old test one, so it's got fingerprints on it and that kind of thing. It's not as nice as some of ours, but this shows you that's where we end up. Very, very light and stiff. Each cone has its own job. If this is going to be a subwoofer cone, then it can be a lot more sturdy and actually have more bracing than the other ones. But we make all of our cones here. And that about is it for cutting. Let's go to circuits and assembly. All right, so we're walking into circuits here at YG. We've got a lot of things going on. We've got some prototypes being made. We've got some circuits being finished. But we have a lot in stock actually that we've already got made and ready. A whole bunch of upgrade kits that will go off to distributors and dealers for installation into legacy YG speakers to bring them up to the current stuff. But you'll notice a lot of orange here. The orange actually is something we're super, super proud of. These are our custom components. We spent 9 months with one of the world's finest OEMs of capacitors that all of the most expensive loudspeaker brands use this company's materials. It's branded under another name. But we went and found these guys and actually started working to get exactly the type of things that we want. We want the type of materials. We want to be able to spec how tight they're rolled. We wanted to spec all kinds of things, what the substrate is,
what's the distance between them, what the temperatures are done at, what, all kinds of characteristics that are specific to our needs. Also, we'd like to not have to be buying from the same pool that everybody else is, because you find part shortages left and right, and sometimes that can really delay the ability to deliver a pair of speakers that someone really wants yesterday. So a lot of things were solved when we went and designed a range of capacitors. You can see these big ones are very different than these ones, but all the orange ones are YG acoustic capacitors, and we're able to incorporate really fine metals that we weren't able to get elsewhere. And so we're thrilled about that innovation. That is not the only component in these crossovers that we make ourselves, but that's where we started. Let's go in to see some finished circuits. I'll show you what we're looking at. One of the things that we're prioritizing in our internals of our speakers is vibration dampening, so absorption of vibration, and also absorption of standing waves and absorption of energy inside the cabinet reaching the back of the cone. And part of that is diffusion. You're always diffusing at the same time that you're absorbing in audio, unless you've got some very specific thing that you're working on. And so what we're doing is we're making circuit cages that act as both diffusers and absorbers. What you're looking at here is a whole bunch of holes drilled into something. But if you know something about the Helmholtz principle, and you notice that there's a certain thickness to this, you will recognize that there will be some Helmholtz interaction with this. There will be frequencies that are pulled naturally through these holes based on their wavelength. In that process, there's a scattering that is really useful inside speakers internally. When we can mate these with a visco kind of rubber material, there's actually a mix of diffusion and absorption going on. We do that in our Carmel cabinet, for example. But let me show you a pair of Haley crossovers. So this would be the base circuit for Haley, the bottom of it, and then this would be the upper circuit for Haley, and this is two different circuit boards mated together. I'll try to not destroy this. So this is what you're paying for in a circuit for one pair of speakers. Actually, it's one channel, one speaker, in our speaker called Haley. You've got very large inductors there that are potted with a sort of visco resin that really dampens vibrations, and they're clamped directly to this thing, which is clamped to our NERC cabinets. But you also have the metamaterial absorption and diffusion of this Helmholtz process. And then, let me put this one down here. What you can see in our upper crossovers is a sandwiching of a couple of boards. And in between, you can see that we've cranked it down so that the inner absorptive material is compressed to a degree. Why is that? Well, that allows it to release and compress. So you're actually maximizing the absorptive characteristics of it. But you can see that every component is really oriented in a very specific way, not just inductors at 90 degrees angles to each other. But we find that having big inductors on your circuit board actually impacts every single component, even resistors. And so we're looking at computer modeled interactions and very specific placements and very specific traces and no right angles, lack of eddy currents, that kind of thing. At this level of the game, absolutely everything matters. And so component interactions matter a lot. And so if we're able to make the components and we're able to control them in a way that we really like, then we're cooking with gas, Our new PCB material, what it is it's a material that has great dielectric characteristics at high frequency and at RF frequencies, and we're using twice as thick copper that YG has ever used, and we of course machine out our PCBs so that we can use and get the thickest traces possible. The goal there is reduction of energy loss in the crossover. We don't want to waste any energy. We want it all to be going to the drivers. And so that's part of that process. That's part of all the innovations of the new YG ownership and the new YG design group. And again, anytime you see orange, that's our own capacitor that we've designed. and in place for the very specific purpose of making the finest music possible. And fans of YG will recognize these inductors. We still make those. We have optimized that too. We've optimized the core of that and found a new way to bake it that really solidifies it and reduces any kind of microphony there and any kind of vibration sensitivity. So, everything matters, and that extends from crossover to feet to drivers to cones, everything in our speakers. And here's the circuit guys here that we're part of it. A lot of speakers, yes, All right, so here we are in assembly. Let's start out. We're going to go through reference, and then we're going to go to peaks. So, with reference, obviously, it's the aluminum cabinets we're known for. From Sonia up, it's 2-layer cabinets. And a new innovation we brought lately is a constrained damping layer between those layers. And also between the different modular portions of the speakers that don't come apart. So Haley's got something between the top and the bottom. But on the bench here, you never know what's going to be happening here at YG because these guys really crank stuff out quick. But it looks like a pair of XX speakers are in progress right here. And I can actually do this. So this is our new speaker design that's got wheels on the bottom and side firing woofers on the side. Actually, that's why the sock's on. The woofers are actually already mounted on this. I think that the wheels will be engaged so you can take a look. But this is the inner frame. And on this side, actually, it looks like the outer is already applied. But these need baffles, but they're in progress and they're about to go to somebody, some lucky customer. And so that's our new speaker, XX, but you can see a number of other stuff already in progress here. I want to say these are going to be XX as well. Boy, I mean, there's just the excitement we've had about that speaker all over the world has been really encouraging. So we've just been making a whole bunch of them.
And that's the one you're planning on sending me, right?
Yes, sir.
All right.
Absolutely. I'm going to send you the passive version. So
yes.
That's actually one we make active and passive, where all the circuitry, let's go back to here, all the circuitry is here. So even the live circuitry, so we make this in a live version, and there's a tray you can pull out, and if you like, you can get the passive version and switch between active and passive at your whim. So we actually have at least one distributor who's ordered that version, and so I think it's a very cool innovation that we're bringing before. But the ability to switch from active to passive in absolute high-end reference loudspeakers is pretty cool. These look like Sonia's in progress, but it's a basic inner design with a lot of bracing. Everything we do is stood off by some kind of sorbo foam, some kind of vibration reducing element. So you see this very fine layer of what we would call weather stripping, but through certain torque strengths and through compression of this material, we believe the tightest air seals of any sealed speaker on the market. It's actually we run into issues because here in Denver we're up at about a mile high, and we sell speakers to plenty of people at sea level. So we actually have to remove screws from our speakers that the dealer will then reattach because the seal is so incredibly perfect. And we've had a number of customers say, I'm not sure everything's right here with this speaker. And I take a look and I say, your screws are missing. That's how fine of a seal that it is, and the whole system as a whole, it falls apart if you have any kind of intrusion of outside air or any kind of air exchange, because we're a sealed loudspeaker manufacturer, and we believe in that for many reasons. But if you're going to do it, you really got to do it. So that's the level we achieve through these processes. We've got another vacuum lift here. It's kind of crazy to see a 300-pound speaker dangling in the air and someone really casually operating a vacuum lift that's a half ton. But that's the way we move stuff around YG. A lot of it's through suction cups and strength and that kind of thing. If not for that, I don't know how we'd move things around so effortlessly. You see a number of Carmel's here on the bench. Carmel's an amazing speaker. It was named after the founder, Yoav's son, and was always kind of a speaker that was just a darling to people. I think in part because we all struggle to bring, massive things into our living spaces and find domestic tranquility, if you will. But the Carmel has been really exceptional at bridging that gap where nobody doesn't like the look of the Carmel. And so in version 3, actually, what we found was a really, really beautiful launching point for one of our finest speakers. It's an absolute representative of the reference range, but it is in such a small package that a lot of people can enjoy it. And it's a bit more affordable than some of our bigger stuff. So we're going to move through to peaks. We separate our peaks assembly from our reference assembly. And so you see a lot of speakers out and getting made. We're able to crank out a whole lot of speakers here in this part of the factory. We are sealed speaker manufacturers, so wherever you see something like this is actually just an access hole for our technicians to be able to get in and maneuver wiring down. But one thing that's notable, if you were to come around, I think you can make your way around there, you can actually see there's a veneered bottom to these. And that's notable because our computer models told us that completing the veneer all the way down was very important for the skin strength of this cabinet. The cabinet's got all kinds of crazy innovation to it to make the wood as similar to the aluminum that we work with in reference. But essentially, our entire crossover is mounted externally on these speakers. Now, it doesn't look that way when you buy them. It looks like one whole speaker. But functionally and electrically, they are external crossovers. So we think we're getting the best of both worlds when we're able to mount the crossover externally. Vibration, mount it with vibration standoffs so that it's isolated completely from the cabinet.
My thanks to Duncan and the entire team at YG for providing me this opportunity and allowing me to share this remarkable visit with you all. I hope you've enjoyed this exclusive, behind-the-scenes look at how these premier American loudspeakers are created. Next week, a sit-down with YG Acoustics CEO and Chief Designer, Dr. Matthew Webster. As always, thank you for taking the time to drop by. Further information on supporting the channel may be found in today's description section or at my website, theaudioanalyst.com. Please don't forget to subscribe, like, and share your favorite episodes. Please stay safe and keep the music playing. Till next time, cheers.